So I have got a lot of stuff that I'm going to try and show you in a fairly short period of time. And most of this is a teaser for the source code. Right? I mean, I spent about a week writing source code, demonstrating a whole bunch of different ways of doing domain objects and page objects. And you can find it all in here. So it's xp-dev.com/svn, automation abstractions. I will move it to GitHub at some point. On my seleniumsimplified.com site, if you look down, I think currently it's 3 blog entries down. There's a listing of a tutorial that all this material was part of. So they've got a longer set of slides already on the site, but I will upload these slides on there. So the aim behind this is, I'm a test consultant, I do test automation, I do technical testing, I go on site, I get to help people with their automation, and I get to see lots of people doing automation in different ways. And there's some people get kind of fixed on certain ways of doing automation, and they don't think through their alternatives, or they don't make decisions about what alternative they're taking. They don't necessarily think through. So I'm going to try and expose you to here are different ways of doing this particular activity in terms of abstraction. I'm not going to give you a definition of abstraction, but for me abstraction is all the stuff on here. It's how we model the application, it's how we model our domain, it's trying to create separation of concerns between our classes to make them maintainable. All the stuff that we normally do when we're doing programming. Modeling the physical world, creating logical abstractions that use that physical world. Now, whilst there are a lot of enormously important things in all the computer books that we read and all the programming books and pattern books, for me, the fundamental thing that I keep in mind when I'm doing abstraction and modeling and automation is this quote from William Blake that I encountered when I was about 20, so it's stuck with me since then. And to paraphrase it, so I'm not going to read it out, essentially what we're doing here is we are trying to model the world, create a system that we are interacting with for our domain, for our application. We could go and bring down someone else's framework and use that, but we will possibly be trapped by that framework. We might have to work around that framework, because it models the technology. We need to model the domain when we are working. So, I tend not to start with other people's framework. I tend to try and just create things that add value, that model the domain that I'm working with. That's what this quote means to me. So here's an example test. You might not be read at the back, I'll kind of skim through it. It's an example test without abstraction. What it's basically saying is, we're using WebDriver here, so we get a page, we find some things on the page, we click on them, we enter some text, then we assert on some stuff that's on that page. It might not make sense logically what that test is trying to do, but we can see functionally that it's doing some things. Now, even though I said it doesn't use any abstraction, it does use abstraction. It uses the abstractions that are given to us by the WebDriver tool. Now, what WebDriver gives us is WebDriver gives us a WebDriver interface that we can use, which is an abstraction around a browser. It's an abstraction around accessing the DOM. It gives us abstractions for Firefox and Chrome and IE, so that we don't have to build that functionality. But they offer us extra functionality that's not in the WebDriver interface. So we can drop down to a lower level of functionality if we need to when we're interacting with a specific browser. We've got abstractions for finding things in the DOM. When we do find something, we've got an abstraction called a web element, which we use to interact with it. So we can click on things and send the keys. These are all provided by the web element abstraction. We've got abstractions for manipulation. So the tools that we use provide abstractions for the technical domain, for the transport protocols, for the things that we are interacting with. Our job is to build abstractions for the domain, for the application, for the flows, for the domain object. But very often it's easy for us to target more of the technical abstractions. So a lot of time when people start with WebDriver, the first thing they do is build a framework to make WebDriver easier to use. At the point when they don't know how to use it, they build a framework to make it easier to use. And then they give that to other people, which locks them in place. Because we tend to make decisions when we know least. And what we really want to do is start working with things and experimenting to get to the point where we make the right decisions. So here's an example test that uses the kind of abstractions that I'm talking about that I illustrate in the code. And it's a little bit easier to read. It's a little bit easier to understand. It starts to expose the semantics of the test. We've got an abstraction for a user, and the user does things on the site. We've got an abstraction for the environment that it's working in. You can see here a fairly human-readable line that says the user opens the application and creates a new to-do. So all of that is a series of functionality. It's not using any frameworks, it's not using Gherkin, it's human-readable in the code, just because we've made abstraction layers that allow us to read it. Having done some stuff at a high level, my test needs to do things at a lower level. So I drop down to a more functional abstraction at a page level. So I've set some things up using the user, then I drop down to the page, then I start asserting things on the page and clicking on things. Now this, I'm calling this a functional abstraction, because I can view the page functionally in terms of things that I do with it. I can view it structurally in terms of the elements that are on that page. Here I've chosen to model those two things separately. And we do this for the same reason we write code in any application for classes, to separate out concerns, to make it easy to maintain and make it readable. It's particularly important for test code that it be maintainable, because the application changes, and it changes all the time. When we write a lot of code that interacts with that thing, we need to be able to change almost as fast as the application code. And throughout the talk, by the way, you'll see that link repeated just in case you haven't made a note. So when I'm thinking about abstraction layers, high-level generic abstractions that I think about, I'm thinking in terms of the data that I'm using. So the raw data, like emails, postcodes. American postcodes are slightly different from UK postcodes. So if I want random generators for those, I think about them in terms of the actual data that we're using. I've got physical abstractions that map onto the application. And very often I'll try and map the application as close to one-to-one as I can. So if the application has an inheritance hierarchy, I might model that in my page objects. If the application doesn't have an inheritance hierarchy, I'm less likely to put an inheritance hierarchy in my page objects, because I introduce a degree of rigidity that the application doesn't have, which makes it harder for me to respond to the changes in the application. I try and model the domain abstractions, all the language that we use when we're talking on the project about the users, the accounts, the whatever it is, the shipping baskets, checkouts, whatever it is, all the language that use the domain objects. They have methods, we can model them. And when we start modeling domain objects, we've got a great place to randomly generate the data. I'll also have higher level things as workflows, those user concepts that do things, the actions that allow me to make my tests more readable. I don't just think in terms of page objects. Very often when I see automation code, what I'm seeing is page objects and hash maps. And that's all I ever see in people's code. So, different ways of doing abstraction. So we've got page objects we know about. Some of them model pages, some of them model components, some of them model widgets on the page. We don't want to get hung up on the fact that a page object only models a page. It models things on the page. We can have DOM element abstractions. So instead of working directly with a web element, we might work with a select object that wraps it with a text box, which gives us more semantics in the test and limits some of the things that we can do in the test when we interact with it. We've got our domain objects. Gherkin, for me, is an abstraction layer. That's really all it is. It's an abstraction layer which has human-readable language, a small syntax change of how we interact with it, and there's implementations for doing that. We might have domain-specific languages. You saw them earlier on. The abstraction code that I wrote was essentially a domain-specific language using a fluent interface to make things readable. For some reason, testers like writing keyword automation. That's an abstraction layer. What I like to see are as many of these as appropriate in the same code base, rather than one. Because what people do is people get hung up on, we're using Gherkin, we're going to use Gherkin for everything. Every test is going to be written in Gherkin. Now I need, for my automation, tests which I can, abstractions which I can use to set up data for performance testing. I need tests which I can write on an ad hoc basis just to experiment with something. I need tests which I can start, get to a point in the application where I can then do manual testing and go forward. Right? I don't want everything to be cast in a specific way. I need flexibility. The amount of times I've come on site and we're using their testing framework, and I've had to use reflection to access lower parts in their abstraction layer that they've locked away because we're not supposed to have access to it, is not healthy. It's not a good way of programming or working with your code. So, when we're thinking about this, it's really important that we think about the abstraction separate from the implementation. Right, we decide we're going to use page objects. We then figure out how we're going to implement. We decide we're going to use Gherkin. We're going to use Gherkin for good reasons. There's different implementations of Gherkin. Now what happens is, people say they're going to use Gherkin. They choose Cucumber. They then start arguing over the fact that Cucumber isn't a test tool, or Cucumber, you can't write things with just say, when the user logs in, then they see this stuff. You have to write given when then. You're not allowed to deviate. Cucumber's a tool. It supports an easy way of writing parsers for Gherkin, or natural language phrase that looks like Gherkin. You can use it in slightly different ways. So, I'm going to quickly summarize some of the high-level parts of what we're talking about. So page objects are the most obvious thing that we work with. People get hung up on the fact that it's called a page object, so everything that they model is a page. They don't tend to model small components, which means you get classes called a page, which are just filled with a huge number of methods that grow over time. And when they can't figure out where to put that method, they create helper classes. So you have the page helpers class, where you dump everything that you can't figure out where to put it. When it gets worse, you have the test automation helper class, where you just throw any function that you've written that you can't figure out where to put it. What we need to do is start figuring out the best place to put these methods, the best objects, and use them in combination with each other. Some of the web apps are single page apps. How does that impact our concept of page object? Do we have a single class that represents the app? Right, these are things that we have to decide when we're working on projects. If we don't make decisions to split them up, our page objects do all of this. Right, they open the page, they abstract how we access things, they navigate through the application, they log in, they have abstractions to type on things. Sorry. I'm trying. I think it might be the smoke when I came in the system this morning. So we have all these different abstractions. Now we could put it in a single class, in a single line, but I like to split them out. I like to have functional pages that just do these things, abstract away the physical stuff onto different pages. For some people that's overkill, right? But the point is, it's a decision. It's a decision that we discussed on the team to make abstraction layers that are appropriate for our project with the skill sets we have, with the processes that we use. There's no right or wrong answers in here. We just have to recognize that we're making decisions about this. So when we've made decisions about whether we're going to have functional methods that abstract away the login process, structural, we have to make decisions about, do we make the web elements that are on the page public, or do we wrap them in methods? When we start making the web elements public fields on classes, then we might start to think we need web element abstractions. So instead of it being a web element, we have a thing called a text field that represents a text field, which lets us append text or prepend text, put text at the front, instead of just working with a web element with all the methods that that exposes. We might have methods like login. Very often you see login pages. Now, when you have a login page, sometimes it's useful to have a shortcut method called logins, where we log in with a username and password. But if, when we enter the username and password, we have an incorrect login, is it still a login? Because what we're doing is we're typing in incorrect details. We're not actually logging in. We're just typing in wrong details. The contract that's implied here isn't quite what we're doing. So sometimes we need lower level. We need physical implementations which have the actual elements that we can work with, and logical implementations where things like login go. We have to make decisions about the navigation that we use. Almost by default, people create page objects that return other page objects. So in the login page, when I submit the form, because I know it's going to another page, the temptation is to return that page from this method. You see that by default. Even though sometimes when I log in, I don't go to the other page because I have to change my password, because I've entered the wrong details. And that navigation flow isn't represented here, even though it's implied by the contract. So what you get things are submit expecting to go to the change password page. Submit expecting not to have logged in because I screwed up. And we get these high-level methods. It may not be appropriate to have that at that point. We can choose to navigate implicitly, where the submit really just does the submit. We control what happens afterwards, and we synchronize on it. We wait for that page to load. We might even choose to have navigation objects. We might delegate the responsibility of knowing how the application sits together in an actual navigation object. Synchronization is one of the most important things that we have to deal with when we do GUI automation, and it's where most of the teams that I see fall down. In WebDriver, we've essentially got two choices. We've got implicit waits and explicit waits. Implicit waits are really a polling mechanism. What we're basically saying is, globally, we'll have a 15-second wait time, where when we try and find something, I'll try and find it. If I can't find it, I'll wait. I'll try and find it. If I can't find it, I'll wait for the 15 seconds. And that happens everywhere that we do these find elements. When you start using implicit waits, you have one mechanism for controlling flaky tests, which is increasing that timeout time. And eventually your timeout time comes to 60 seconds, and your tests start going slow, because some of your tests say, I don't expect to see this thing. So you do a find element, expecting not to see something, and it takes 60 seconds to time out. So I have a bias towards explicit waits, where I do something. I know that the application is going to change state. I wait for that state to have finished, then I move on to the next part. Now we have different ways of implementing page objects. We just got normal, plain old Java classes, whatever classes we're doing. It's a concept called page factories, where we use annotation on elements and automatically convert them into web elements. We have interfaces that we might use. So if we just do plain old Java objects, all our pages might be different. So we might want to have interfaces to standardize how we deal with loading the page, standardize how we deal with synchronizing on loading the page. So I'm going to quickly show you some of these implementations and some code associated with it. So with a plain old Java object, there's nothing complicated in here. Right? We pass the driver into the constructor, we get the page, everything is in a method, there's no standardization, there's no inheritance in here. It's an easy place to start, and the reason it's an easy place to start is it's code. We can change code, it's fungible. If we don't like this, we can refactor it into something else. If you don't know how to use WebDriver, if you don't know how to model your application, start with just normal objects and refactor them. What people have a tendency to do is immediately start to put inheritance and hierarchies in here. To immediately start by looking for libraries that stop them having to write methods to find things and return things back. That's so they start looking at page factories. I personally like to start with plain old Java objects and keep with plain old Java objects. But I do split them into functional and structural type concepts, because it helps me split out the what do I want this page object to do? What do I want to use this page object to do? Now sometimes it's just a naming convention because I get nervous when the thing that I'm using doesn't fully correspond to the name that I've given it, but sometimes it really makes a difference, because what you find is when the application changes, if you're having to change your abstraction layers in 100 different places, you don't have the right level of abstraction you need for your particular application for the changes that it is undergoing. By having these kind of separations at the start, I'm more likely to get towards the type of abstraction layer that doesn't need changing everywhere. So to give an example of page factories, I used to use page factories a lot. Page factories are basically, instead of having a whole bunch of methods that abstract around the web element and I have to write code to find them, what I do is I annotate them with @findBy. So I essentially declare how we find this element on the page. Then in the constructor, we have something that uses reflection to go through and puts proxy objects on each one of these things, so I don't have to do the hard work of figuring out it's a web element, find it, this is how we access it. Now the problem I found is that when I was using this, over time I would eventually have to unwind the page object because the application would get a bit more complicated. I would need more synchronization on this than just waiting for it to be there. I need to be in a certain state. I need jQuery not to be running. There's a tendency then to create your own web elements and put them in here, but then you have to change the factory method that uses reflection to go through and populate them. So it might be the perfect fit for your application if it's simple, so don't rule it out. It might be that you start here, but have to change it over time. Personally, I try and avoid it from the start because I know that I'm going to have to change it over time. But it depends on your team. Slow loadable component is an interface that comes with WebDriver. And it's basically a way of saying some of our pages need synchronization when they load, right? Because although WebDriver blocks to a certain extent for the HTML to come in place, as soon as it's loaded, we go off to the server, bring some AJAX back to populate some parts of the page. WebDriver doesn't know that. But it's a slow loadable component, and we have to wait for the right circumstances before we interact with it, otherwise our test will fail. We don't want to do that just on a wait 15 seconds basis, because in some environments it's going to be slower than others. So what we want to do is wait for the right state. Now when we have a slow loadable component, we have a standard interface for doing that. That's all this really is. So we get a get method for free, so we say page.get the page, and then we assume that it's going to be synchronized because we're going to implement an isLoaded method that basically says, is it loaded? And throws an error if it doesn't. And it gets called during this. It says load the page, then poll, is it loaded? Is it loaded? Is it loaded yet? Is it loaded? When it has loaded, based on what we put in here, then we're ready to work with it. So it kind of formalizes the notion that on page load, we have to synchronize on that page. Now, it doesn't mean that's the only place that we do our synchronization. We sometimes have to do synchronization before we interact with the elements on the page. So we need the ability to put synchronization in different points in our page object. So I use this concept all the time in order to make things readable. Just fluent interfaces on the page objects and the domain objects. And it's essentially just, I'm putting in syntactic sugar with and then, and, so I can chain the method to make it readable. And any method that doesn't move on to another object is a great place for me to just return the object itself and then chain all these things together. So anything that would normally be a void, you just return this back or return self or whatever the concept is in your language. And the syntactic sugar is what makes it look readable when we see it in the code. A lot of people don't like this on teams when we discuss it because they've read clean code and then they've heard about the concept of train wrecks, so they don't like seeing methods being chained all the way through. For me, when it's the same object and it would normally return void, I see no issue in returning self and chaining that, because it's almost like a builder part that's doing something in the same context. So I like this because it makes it readable. And the thing we've got here is test code, test automation code, is often built to different standards than development code because it has to change more often. It has to be readable. We have to use it in different places than we might use the application code. Application code hangs together as a system. Very often the test automation code is being used at a small chunk. It's being used in big system places. It's being used for something entirely different than being expected. So we need to build in the flexibility to allow us to do that. So navigation options. So I don't use a lot of navigation objects. So very often I will have an object that lets me go to places in the application. Very often I do go directly in the test to certain places in the application. I tend to do navigation as a side effect, which means when I click on something, I know the application is going to navigate at that point in the context of the test, so I wait for it to be in that point in the test. What I do not tend to do is have page objects that return other page objects for the reasons that we mentioned before. When you log in, if it's an invalid login, you're actually still on the same page, and you have to ignore the return value. When you log in, you change password, you're on a different page. How do you do that? You don't really get polymorphism with return objects. You get it for objects that you're putting in. So sometimes it's better off not to return something and not to cope with that. There are classes in certain languages. I think in Ruby, Jeff Morgan has got a navigation library, which basically says, I am on this page, navigate to this page. And it will do all the cool things to click through your application to get to the right place. I tend not to need to do that. It's a tempting, shiny thing to implement. but I've never actually been on an application so complicated that I've needed to do that my tests have been hard to read as a result of not having that. But these are options. And we shouldn't rule them out. We need to use the ones that are appropriate for our application. I have domain level abstractions. All the code that you'll see in the code base is on the to-do MVC application. Given that, some of the domain objects are going to be to-dos. It's going to be to-do lists. Now, because these are domain objects, I can randomize data with it. I can maintain a kind of test state and then check the actual values on the page against the test state using the domain object. I have high-level objects that do things, scenario objects, workflow objects. I'll try and find the right place to put this to conceptualize it. Now, as soon as we start introducing domain objects, we then have another choice to make. Should our page objects understand the domain object? Instead of typing in page, enter to-do item, here's the text for the to-do item, should I be able to say page, here's the actual to-do item represented from my domain object, use that? Now, given that I don't like page objects knowing about other page objects and the flow through them, I tend not to let page objects know about the domain object. So what I will do is I will use the kind of higher order domain objects, the user objects, the workflows, the scenarios that flows through, to make that mapping between the domain object and the physical world, how it is fed into the page to work with it. Now, it's a strange warning. I'm going to tell you not to overthink this stuff, given that clearly I have overthought this stuff. But the reason I'm putting this together is what people do is they have paralysis before they create anything because they overthink it at the time. Because we know we have all these options, instead of just getting on with it and creating some page objects, adding some value into the stories, creating some stuff that works, we go away and have an argument about should we use this framework? Should we be using page factories? Should we be doing this? Should we have... And we have all those arguments with no actual examples, with not actually implemented anything in the project, not knowing whether any of this actually works for us or not. So the main point is, just get started. If you're not sure, try and experiment with it. See how it works. It's code. You can refactor it. You can put libraries in. You can put abstraction layers on the libraries if you're not sure whether you're going to keep that library. But it's important that if we are ever having to work around our abstraction layer rather than work with it, then we've got a problem, and we need to fix that. That's one of the main things that guides us. If we're having to maintain too much, if developers can go in, make a quick change in the app, and they're done, and we have to spend a week fixing our tests, we've messed up our abstraction layers. So that's what forces us to rethink it. So the DOM abstractions, things that would abstract away a DOM or a select or an option or a list item or an anchor. The reason we do that is that it makes it more semantic in the test. So if I'm working with a checkbox, I've got a checkbox on the page. If I don't have a DOM element abstraction, I've essentially got a web element. If I want to make that checkbox checked, I have to first of all say, is it selected? No. Okay. Click on it. Is it selected? Yes. Okay. Don't click on it. And it's not the same as check it, which is a contract that says when you call this method, after calling this method, the checkbox in the page will be checked. We have to write extra code around it. So in those kind of instances, and the only thing that we ever want to do with the checkbox is check it or uncheck it. These things make sense. I probably wouldn't include a toggle in a checkbox. But the thing is, when we do this, we can enforce the semantics and make the test more readable. And the question becomes, do you return these things back into the test level? Should the test be able to access them? Because of the controlled semantics, I see no reason why not, but some people choose not to. Now, I have a tendency not to use these in the real world, simply because I've had too many bad experiences of people doing them in page factories, and then having to work around the implementation in order to deal with new elements that have been on the page. But under certain circumstances, where they're kind of wrapper methods around something where I pass in a web element, it's fine. And when I do use them, I always make sure that I can access the web element that they wrap around. Right? I don't want to have to somehow use reflection to access a private field inside this checkbox to get the web element because I need to check the attributes on that web element. I don't want to have to do that. I want this class to support that extra exploration and not lock me out. So I'll let teams pretty much do what they want, so long as we have that flexibility to use these abstractions how we need to. So we have pages that have headers and footers or sidebars. These are components, these are widgets. These are ways of constructing the page. Very often I turn those into objects. Very often they are slow loadable components because the header might take some time just to settle down because the CSS moves things around and it's not quite ready to interact with yet. It's slow loadable in the sense that it loads fast but it's not ready to interact with yet. And by delegating that responsibility for synchronization off to a component, then it makes life easier for me. Now what very often happens is because you've got a page with lots of components on it, people start creating inheritance hierarchies. Right? So we have page with header and footer, and then our new page will inherit from that, rather than just compose the objects together. So if your app has an inheritance hierarchy, and in the actual code in the templates it has an inheritance hierarchy, then feel free to model it. If it doesn't, then you might start getting in a mess when they come up with a completely new page that doesn't fit your inheritance hierarchy. When we do have the component abstraction, basically instead of the page having to do all the work, the page just returns the component and we work with it. So here the page is actually having to do all the work. And you might find that if you've created a component and you've composed the page with it, the temptation is to just stick a high-level wrapper on that particular page because you don't need to drop down into the component. Sometimes that happens. So Gherkin, for me, is just an abstraction there. This might be the most contentious part of the talk because people have really strong opinions about BDD and they conflate BDD with Gherkin and Cucumber. Gherkin is a natural language representation, and we use it when we want to communicate. When we use it in our tests, very often what happens is instead of focusing on expressibility and making the test express just what is needed, we focus on step reuse. So we make it easy for us to not write any more code. So instead of having a single, when the user does something cool here, we try and build up the scenario from things that already exist. That's the temptation because it's an abstraction there, because we've already implemented stuff in the past, and because we've confused why we're using it. We're not using it for expressibility. We're using it as a test tool. Even though we know in our heart of hearts it's not a test tool, we promise everyone it's not a test tool, that's how we're using it. Now I quite like Gherkin, even when we're not doing BDD, because it makes data-driven stuff really easy. It's really easy to build a table in Gherkin, a lot easier than it is in JUnit. So I will use it for that. I'm quite happy to use it for that. Because what happens is, these feature implementations use all the other abstractions that I've built. So I'm not writing code directly in here. Chances are I'll already have JUnit tests that are doing all this with page objects. So I'm not building it in the Gherkin feature files. So this is just another abstraction layer I'm sticking on top, which is using all these other abstractions. So I think it's really important that you look at your abstraction layers and you look at what your current biases are, right? Because they may be stopping you looking at alternatives, looking at different ways of doing things. My biases are to make sure that when I construct a page object, I inject the driver in through the constructor. I don't like having big frameworks where these things are globals and I pull them in. I like to have simple objects where whatever that object is using comes in through the constructor. I like to have explicit synchronization. Implicit synchronization makes me nervous because I think as soon as we go onto the remote grid and try a different device, the synchronization isn't quite in the right place for that, and the implicit synchronization doesn't work, and then we have to spend a lot of time debugging those tests. I tend to do navigation as implicit. I click on things, I expect the navigation to happen, then I synchronize on it. I do have explicit navigation options for opening pages and jumping to them, because I don't necessarily think the page should be responsible for opening itself. I want the page object to be something that I use to represent what is in the DOM at this point in time. For me, it's just a DOM representation. So my test knows what's going on. It pulls out the DOM representation that it's expecting. I do tend to model the physical world, and I'm very conscious of modeling the physical world and giving people access to it. Then if we want to simplify the access to it, I'll put a logical functional layer on top. I create domain objects. I tend not to abstract the web elements. I'm very conscious that I don't do that because I've been bitten before. But I can see a lot of value in there, and for some instances I do try and use it. Problem is, there's not an awful lot of easy to get hold of web element abstractions. They tend to be buried in frameworks. So in order to get them, you have to get the entire framework, which then causes people to use it and buy into a new huge part of code. So I tend not to use third-party abstractions on top of WebDriver, simply because WebDriver is really simple. Basically, you find things, you use them, you wait for stuff. That's it. That's pretty much WebDriver. So all the third-party abstractions which make it easy to synchronize or not think about what you're doing, it makes no sense on the systems that I've worked for with the people and the skill sets that we've had. Right. But it's important. You might have rights or wrongs in your environment because of your teams, because of the standards that you've done. That's fine in your context. But I don't think that we should rule out any of this just because we have a fixed opinion on it. But it's important to recognize that you're making decisions when you use this. And understand that you've made a decision on one thing, which means you've rejected something else. Now, if you mix decisions, like say some of your page objects return other page objects, but some don't, then it means that the next people come on, the new people come on your project, have no idea which one to really do. And they might pick one that that is slightly inappropriate because they're inexperienced with your app and your team. So there are other discussions of this if you do want to investigate it in more detail, and I think you should. Jeff Morgan has an entire set of abstractions for Ruby around navigation and page objects. It's worth having a look at those. There are generally some good talks on the Selenium conference that cover this kind of stuff. I picked out two, one by Marcus and one by Anand. And do have a look at the code that I put in here. There's a lot of code that shows this in action, shows the logical page objects using the physical page objects. So that's your homework. I know people don't like coming to talks and getting homework, but you've now got homework. If we get the camera to pan around the audience, then we'll see exactly who's here, and we can check later on whether you've done the homework. But do check it out if you're interested, because it's the best way I have of explaining it in the code. Because we're working with code, we're programming. The code is the ultimate source of truth for what we do. So if you need any more information on my stuff, it's there, but fundamentally, there. I will be putting the slides on the Selenium Simplified site, so you can go there, seleniumsimplified.com. Now I think we have about 2 minutes if there are questions. Are there any questions? Yep. So the syntactic sugar, essentially if it was an AND method, how does the syntactic sugar work? If I wanted an AND method, basically AND, the entire context of that method would be return this. Then would be the same, I'd just say return this. Which means that I can chain these methods, because we've got the same object, and we just use the objects, the methods on that object. Any other questions? Okay, feel free to grab me afterwards if it's a private question or anything else. Otherwise, thank you very much for your time.